Hello guys, this is Paul McWhorter with TopTechBoy.com and we're here today live. And are you guys ready to rumble? No, we're not going to rumble. Really, we're not going to rumble. I shouldn't joke like that. Because I have a feeling if you guys ever started rumbling, you probably would not stop. Okay guys, let's see. You guys check in. Let me know who is out there. It looks like we have Lee. It looks like we have Chase. It looks like we have Daniel. It looks like we have Vaughn. Okay, so we've got a little bit of an audience developing. You guys check in so I can give you a shout out because I have got a really exciting live stream for you today. And what we're going to do is we are going to look at the question, is the Raspberry Pi Pico the Arduino Killer? Hey, we got Peter here. Welcome, Peter. Always good to have you check in. And I almost forgot to mention, Daniel, you have to go. I'm sorry. You will be required to stay here. No leaving in the early part. He left anyway. I forgot to remind you guys, I will need you to pour yourself a nice strong glass of iced coffee. Since it is 6 in the morning here and I have been up since 5 o'clock in the morning, I also have a rich and creamy cappuccino. Yes, jet fuel, dual jet fuels this morning because I got up early and I am going to need it. Okay, you guys check in so I can give you a shout out here, looking at who all we have. But I'm really excited about the lesson today because I really think it's important for us to every once in a while kind of go back and look at these single board computers and sort of see where we are and see what's available and see what direction we can be going in the future. And you guys give me kind of an audio check. Does everything clear? You can hear me clear. The stream is going good. I need to kind of know if everything is all tuned up properly in my studio. So you guys leave me a comment. Let me know you're out there. Hey, yeah, we've got Midrar there. Lee says that things are okay. Chase says things are okay. That's good. That's good. Okay, Vaughn says things are looking good. Oman, hey, welcome. Oman is one of the guys that comments a lot on the videos. And so Oman, appreciate your participation in the community. We've got Navneeth, welcome. Okay, the Fleets, welcome. Aether Guy, loving the videos. Not a lot of time to work with electronics for me for now. I have a newborn. Oh my goodness, those newborns do take up a lot of time. We've got Oman, Colin, Tom, Larry, Pascal. Hey, Pascal, haven't heard from you in a while. One of our regulars. It's always good to see you there. And Aman, another one of our young and up and coming engineers. It's always good to have you young guys on. Rob, hello. Okay, Saban, hello. And guys, I want to give everyone a shout out, but I apologize if I'm butchering your name. I give it my best shot, but if I don't say your name right, please forgive me. Neophyto, hello. Okay, guys. Cyril, hello. Hey, Cyril, you leave some comments too. We really appreciate your participation. Adam, hello. Welcome. Okay, guys, so let's get, I'll continue to try to interact with the chat, but let's get to today's topic. And today's topic is the Raspberry Pi Pico going to be the Arduino killer? So let's try to see if we can put a little context on that. And as I was putting this together, hey, Brian, I was thinking that maybe instead of calling it that, the title should have been a trip down memory lane. Okay, because here are some of the single board computers that I have been working with over the years and kind of just thought we would kind of step through these and talk about what's where and what does what and how we sort of ended up where we ended up. Does that sound good? Hey, landlord, good to see you. Brian, good to see you. Okay, now I gotta ask you guys, do you like this overhead technical engineering shot better, or do you like the boom shot where I'm kind of coming in sort of like this is your Ferrari shot? You know how they take pictures of cars? That's the sort of vroom shot there. Or do you like the technical overhead shot better? So you guys let me know which one of those shots you like better as I go through to kind of point at these different. Okay, Aman is the technical guy. Rob is the technical guy. Savan is the technical guy. Okay, man, I would have thought that you guys would have liked the vroom shot. Okay, Wayne is top. Oh my. Hi, Dan. Well, it's always good to have you here, Dan. Okay, so it seems like it's pretty much unanimous. You guys like that. Okay, Kate is giddy. Okay, Kate, I am giddy as well. So please welcome. It's great to have you here. You see, I really like that shot better. I kind of like the drama of that shot. But I listen, and the people have spoken. So we are going to go with the overhead shot, okay? So let's talk about single board computers, and let's start with, our old friend, the Arduino. This is one of the clone Arduinos, but it's basically an Arduino Uno R3, and this is kind of the mainstay of the Arduino world. And what are the great things about the Arduino? Because the Arduino was the first single board computer that I ever used. And the bottom line is the Arduino is simple, and it just works. Okay, it's simple and it just works. And I got to tell you guys that, I spent an entire career working as an electrical engineer, but I had actually not coded since way back in the mid 1980s. When I first got an engineering job, I was writing computer programs to do physics simulations, and I was writing computer programs to do instrumentation and testing. So I would program test equipment to test integrated circuits, and so I had to code back then. And most of the coding was in something like Fortran or HP Basic. And so I was coding back then in the mid 80s, but then I got really involved in the physics of things and the solid state physics of integrated circuits and transistors. And so I got away from coding kind of mid 1980s. And so it was sort of like I didn't code for 30 years, and I had never done anything like code a microcontroller. And so to me, when you wanted a microcontroller set up, you'd hire someone and they would do that part of the project. But I did not have a clue. I did not have a clue of how to program a microcontroller, and I hadn't programmed anything in 30 years. So I was a complete novice, but I really thought that we should try to start incorporating, like programming and circuits and things like that into the education system. And, I was teaching math. I thought, wow, we ought to try to do this. But I thought that it was impossible to code things like this. But I remember on YouTube, I saw a video, I believe, by Jeremy Bloom, and he showed a quick video on the Arduino where he just plugged it in, and he wrote like 5 lines of code, and he turned the LED on and off. And when I saw that, wow, I understand what he's doing. If you can turn that LED on and off, you can turn the GPIO pins on and off. Then I saw you could read from the GPIO pins. I realized at that point, the world is my oyster. With this Arduino platform, I can do anything. I can read anything. I can control anything. And so I just really, really jumped into it. And I just thought that it was absolutely amazing. Fell in love with the Arduino. Now, what are some of the really great things about the Arduino? Number one, it's simple. It just works. It works simply because there's no operating system. You just power it on, and as soon as it has power, whatever code is downloaded into it, it just runs. And then what that means is that if it's in a deployed environment and for some reason there's a noise glitch or a power glitch or some problem, when the power comes back, it just immediately starts running the program again. So it's just the program runs on power up, and therefore it is just a really, really easy system to deploy. Now, other things that I found absolutely amazing about the Arduino is there is a huge user base and community. There are many, many people using this. And I know along the way there were a few different variations that people were working with the Arduino, but pretty much they all worked exactly like the Uno. And so everybody was working on the same hardware, and everybody was using the same IDE. So everybody was building momentum on this platform, and that was good. What happened then is there was lots and lots and lots of hardware, sensors, actuators, all types of things that were created to work with the Arduino. And with that, there were lots of libraries. And so if I wanted to connect, let's say, an ultrasonic sensor to the Arduino, I could be assured that I could find a library that would make use of that ultrasonic sensor very easy. So you had a whole lot of libraries and you had a whole lot of hardware. Then also, because there were so many people using it, that almost anything that you might want to do, you could be assured that someone out there had already done it. So you could find tutorials, helps, examples for just about anything that you might want to do. Just about anything that you might want to do with the Arduino, chances are you could find some resources on that. Okay, the other thing which was really, really, really important is that huge user base. It was very friendly. They were really nice people. And so if you were new and you had a question, you could ask them and there would be someone that would jump in and help you. And so it was an incredibly nice and incredibly helpful user base. So when you went on the forums, you would always get lots of answers and lots of help, and everyone was very friendly. Okay, so with all that being said, why don't we just sit back and enjoy the Arduino and spend our life working on the Arduino? Well, there are some limitations. Amon, that is not a power supply. That is the NVIDIA Orin. This thing is like the most unbelievable single board computer brick that has ever been made. I think it has 4,000 something processors, and it is able to do 275 trillion operations per second. 275 trillion operations per second. It's hard for me to even describe the magnitude of the computing power in this board here, okay? But Amon, you got ahead of yourself there, okay? But let's go on. So if the Arduino is so great, why don't we just do the Arduino? Well, there's a couple of things that turn out to be some very fundamental limitations, And one is the Arduino has limited memory. And I'm talking limited memory to where I've done things where, like, let's say I want to run a GPS, and then with the GPS, I also want a pressure sensor, I want a temperature and a humidity sensor, like a few simple sensors. I have run out of memory on the Arduino, and there's no way to really add more memory. So when you hit that end of memory point, there's really no way that you can get around it. And it's very hard to optimize the code to try to squeeze more into the Arduino. So I have, on a number of projects, reached the point that I was just flat out of memory. Okay, just out of memory, and got shut down because I didn't have enough memory. Okay. So that's limited memory is one limitation. Another limitation is the way they put these headers on here. They're designed to mate with male wires. So you just plug the wires in, and then you bring the wires and plug them into the breadboard. And that's so easy. That makes it so easy to make projects because you just put the little jumper wires for the desktop or the bench top. But that's not good for deploying systems because you can't have just all of these loose, loopy wires to build a prototype or a project that you would deploy. And so kind of a problem that we have here is that it's not very convenient for actually making a prototype that you would deploy. Hey, let's take a look at the river over here. Okay, you can see that the sun's kind of coming up on the old River Nile this morning. I could see some fishermen out there. We'll check back every once in a while to our river cam to see what's going on. So the issue is that these headers are not really what you would prefer. The memory is somewhat limited, and then finally, a really big issue is there's really no connectivity or limited connectivity. The only way you can really communicate with it as it's configured is through the USB cable. Okay, you communicate with it through the USB cable, and if you want the project over there, then you better have a long USB cable, or there are some things like the XB radios. They're like, you can plug the XB radios in and you can try to do things like that. Now there are some shields. I know that there's some shields and some things that you can add Ethernet, or you can add Wi-Fi, but as you start doing that, you start getting into an area where there's not as much support, not as much expertise, and it turns out to be really, really hard to do. So once you get to the point of needing to deploy a project, you've got the problem of the headers aren't really right, and you don't have connectivity. Now, what I should mention is along the way, they did come up with the Arduino Nano, and the Arduino Nano is pretty much exactly like the Arduino Uno, but just smaller. All the same code works the same, everything works the same. It's just a little bit more of a deployable thing. So you can see with the Nano, you've got the pins like this, so you could plug it into a board, or you could plug it into a PC board and solder it in. So this a little bit helped with that ability to incorporate into a system, but still you've got the connectivity issue and you've got the limited memory issue. So I was so excited. Arduino went from the R3, then they introduced the Nano, and I was just waiting for the next big thing to happen with Arduino. This is like 10 years ago, but then I'm sorry, it just seems to me like Arduino sort of lost their way. The whole thing about Arduino was dead simple, just simply works, and then all of a sudden you went to their website and they had 50 different boards, and there was the ARM MKR with the x86, and there was just all this jargon and lingo. And I couldn't even figure out, like, what board do I want? Where am I going? What does this do? It was giving me little detailed, deep in the woods technical jargon, but it wasn't telling me, hey, look, you can deploy this with this, or this is for this. And because there were so many different boards, there wasn't really any momentum behind any one of them. So I'm sorry to say, as much as I love the Arduino, after the Nano about 10 years ago, Arduino sort of lost its way, and they forgot what made them big and forgot what made them great was simple, just simple. It works, and all of a sudden it became a platform more for the experts. And I think that was kind of a problem. Okay, I think that was kind of a problem that Arduino lost it their way. Okay, so you reach the point that you need more horsepower, you need more memory, you need more connectivity, so along came the Raspberry Pi. Now, what did the Raspberry Pi do? The Raspberry Pi had gobs and gobs of memory. For projects, you would never run out of memory on a Raspberry Pi. It had Ethernet connectivity, and then even though this was an Ethernet cable, it later came out with Wi-Fi onboard connectivity, so it solved the connectivity problem, it solved the power problem. But then what was why don't we just all go to the Raspberry Pi? Well, there's some limitations on the Raspberry Pi as far as deployable projects, and let's talk about those. What were those limitations? Well, first of all, this is not a microcontroller. It's a microcomputer, or a mini computer, or a computer on a board. It's more like a full computer, and it has its own full operating system. And what does that mean? Well, it means that it's fast. It means it has lots of memory. It means it has Ethernet. It means it has Wi-Fi capability, and it gave you access to the GPIO pin, so that was good. So as you wrote your programs, you could access the GPIO pins. All of that was really, really good. But then what is the problem? The problem is, because you have that operating system, you're running Linux. If you have any little glitch, like electrical noise that shuts your system down, or a power glitch or something like that, you can very easily corrupt your operating system, okay? That you can't just jerk power or send a noise signal at the Raspberry Pi, because if you get a glitch and don't shut down cleanly, you can corrupt your operating system, which means if you're trying to deploy a product or a prototype, you can't have the user have to go down and reinstall the operating system if it got corrupted. And so that turns out to be a pretty big challenge. You lose that it's simple and it works part. You lose that it's simple and it works part. Oh, Kate is checking out. Okay, check in tomorrow and watch the rest of the video. Kate, thanks for stopping by. Okay, and Savan, hello. I see a couple of you guys have come in. Okay, we'll check out the river view again. It seems like you guys like looking at the river. Okay, yeah, the sun's coming up. I'm sorry I didn't point the camera better. It was just dark when I was pointing the camera, so I didn't get the perfect. The perfect shot. So let's come back over here now. Okay, so the operating system can become corrupt fairly easily, and that's a pretty big problem. It's difficult to run the system on boot. So if you just have a little box with a Raspberry Pi in it and plug power on, it's hard to get it where it boots and it goes in and configures and it goes in and runs the programs that you want to sort of bring the system up with your programs running just by plugging the power in. Okay. Also, it doesn't just have like an on-off switch. There's not just a simple button you click to cleanly turn it off. If you have a deployed system, kind of like the way you end up having to turn it off is removing the power, and then that can corrupt the operating system. So it's not really configured for the novice to make it run well in a deployed system or a prototype. And again, you know, it is possible to boot up and run all your programs the way you want, but it starts taking a lot of higher end expertise to do that. Colin, we will be getting to the ESP32. So just, you know, we're getting there. We're getting there. Okay. Also, the Raspberry Pi tends to be confusing. It's not just, okay, learn how to code, learn these commands to really use the Raspberry Pi. It's not just knowing Python. You've got to really get into the ins and outs of Linux, and that can start becoming much more difficult. Also, the kind of momentum behind the Raspberry Pi did not go towards embedded systems and projects. It went more towards retro gaming, and it went more towards like media devices, like something where you would stream music or you would stream videos from a device. So sort of like a home media center or a retro gaming center, and the old sort of Bill Cool projects based on the GPIO pins, that seemed to not be the direction that Raspberry Pi went. So there were much fewer examples and much fewer libraries out there as compared to, yes, Ruben, that's a Jetson AGX Orin on the top right with something like 280 trillion operations per second that it will do. So less hardware, less libraries, that's kind of an issue. And then, okay, this is where I get in trouble, and I know I shouldn't say it, but I'm going to say it anyway. A problem with the Raspberry Pi is it operates on Linux, and therefore it's Linux guys that are using it, and I don't know why, but Linux guys are like really angry. Okay, they're like angry people. And when I say that, then all the Linux guys come in, how can you say the Linux guys are angry? And they kind of go crazy. Well, there you go. Linux guys are angry. And so it's very hard to get help on the forums and in a lot of the user groups, because you come in and yeah, there you go, Cole. We're not angry. And you know, I'm kind of just joking a little bit, but really it'd be like, let's say I have a problem. I'm trying to get the Pi to pass data to the PC, to a Windows machine, or I'm trying to see the Raspberry Pi on my Windows network, and I post now I'm doing this, but I'm not seeing the Raspberry Pi show up. Can somebody help me? And someone comes in, format your C drive on your PC and install Linux. Okay, you know, that's not helpful. That's not helpful. Okay, so what I find is, and I don't know why the Linux guys are so angry, but it's like when you try to get help in the Arduino world, it's like everybody's your grandpa. Okay, everybody's real nice. When you try to get help in the Raspberry Pi world, it's more like, you're not worthy, you're not one of us, and because you're not one of us, we're not going to help you. And like on the Stack Exchange Raspberry Pi forum, I like tried asking 3 questions. And this is like, I'm not a stupid guy. I tried 3 days to get something figured out. And only after I was completely hung, legitimately, I gave a very simple, straightforward question. And then they would erase it for violating their terms of service. It was like, well, it's like everybody else's question, but I'm not one of the club, you see. So there's this attitude among Linux people that you're not one of them and you're not worthy, and therefore they're not going to answer your question. So the best you can hope for is to look through the forums and find someone that was a Linux guy that asked the question, and then they answered his question when he asked it, and then it works out okay. Let's see. I haven't gotten a lot of, maybe the Linux guys stopped watching me, but has anybody else noticed that, or is it just me? I'm just like somehow, misreading this thing. I don't know. I hope you guys will leave me a comment there. Let's check the river again. Okay, river's looking good this morning. Okay, now all that stuff maybe I could get around, but this was kind of like the killer for me in using the Raspberry Pi in an embedded system. Elitism exists everywhere, just more so in the Linux crowd. That's probably true, Elam, but I think maybe the difference is with Arduino, it was home hobbyist, and it was not this, I'm a professional, person where that elitism exists. But I do think Elementarinator, I kind of think that you're right. Okay, the Javid X's non-Discord channel is really friendly. Okay, I'll have to check that out. Okay, it seems on Stack Exchange, most people who answer question go out of their way to make the answers. Yeah, it's just, I don't know what's going on with Stack Exchange, but it's hard for me to really understand what's going on over there. Guys, we'll spend 3 hours figuring out a way to tell you your question was already answered. Yeah, Pascal, I know. That's kind of what I'm finding. Okay, what is the killer for the Raspberry Pi in an embedded system or a prototype or something you want to deploy? It doesn't have analog in. And how many sensors do you need to use where you need to measure resistance or measure a voltage? A whole lot. And I'm just surprised as we went from the Pi 1 to the Pi 2 to the Pi 3 to the Pi 4 and all the intermediate ones, they never added the analog in. Any course on the Orin coming out soon? Ruben, no, because the Orin is not available. It's like you can't even buy it. And I'll talk a little bit more about it's like this thing that is like the most amazing thing on the face of the earth sitting on my desk. And maybe I'll talk a little bit about what my challenges were with moving forward with that particular board. I'll tell you, on the Jetson Nano, I spent 1 year making a class on the Jetson Nano. I spent 95% of my time that year on that Jetson Nano class, and it generated 5% of my revenue. So I spent 95% of my time on a board that yielded to me 5% of my income. And so that turned out to be a rather painful investment that I made in that board. But we'll talk a little bit more about the Orin later on. But no analog in is kind of the killer. So you say, well, you can use an ADC chip, which you can see I have set up here. But what that kind of means is I've got to use this ribbon cable. I've got to connect it to the GPIO pins. I've got to come over here with this, and then I've got to have this ADC chip. And then this does not work as well as a built-in on-board one. You're more susceptible to different little problems. It doesn't work as well. And when you take this and you take this and you take this and you take this and you take your components and then you add like a battery, now your project is starting to look something more like a shoebox than something that would fit in your shirt pocket. And so even though you can do things that way, it is not really, to me, a very good way to do them. And so with that, then they came out with the Raspberry Pi Zero and the Raspberry Pi Zero W, and that was kind of exciting because it got a lot smaller. They got down almost to the size of the Arduino Nano. And the Pi Zero, the kind of cool thing is you could buy them with the headers on, or you could put your headers so that you could put your headers so that it would plug into a board, or you could put your headers the way that you wanted them to make it work. But still, all the problems that you had with this because they didn't add the ADC chip. And so that is kind of where we are. Let's see. Let's see, Alan, I find that almost every small project I design does the job. Okay, yeah, we're going to talk a little bit about that, Alan. That's kind of where I'm going. So sort of where I ended up is, this is where I ended up as far as the projects that I was doing. And, I did a lot of the high altitude ballooning where my students would send electronic instrument packages to like 130,000 feet, above the Earth's atmosphere, where you could see the blackness of space and the curvature of the Earth. It was really neat. So we did a lot of projects based on that. And this is what we ended up with. If you can do it, if it can be done on the Arduino, it should be done on the Arduino. And if it absolutely positively could not be done on the Arduino, then you would use the Raspberry Pi. And usually what our devices would have, what our projects would have is they would have a Raspberry Pi for connectivity and memory, and then they would have an Arduino for doing the interaction with the sensor. So all the work with the hardware and the sensors and the actuators was done with the Arduino, and then it had a simple USB connection to the Raspberry Pi, and then the Raspberry Pi could connect through Ethernet, Wi-Fi, whatever. And you say Ethernet to space. Yeah, we actually did Ethernet to space. We had a 70-mile Wi-Fi connection from our classroom up to our high altitude balloon, which is like 20 miles high and 60 miles down range, and we could maintain a high bandwidth Wi-Fi connection over that. That was pretty cool. So where we ended up was we did everything that we could on the Arduino, and then we did what couldn't be done, we would do on the Raspberry Pi, and then we would have those two working together. Okay, let's see. I've got some comments coming in. Hi, John. How are you doing? Great to see you. And no, there's not going to be an Orin class. Okay, Sunil, welcome. Okay, we're going to talk about the ESP32. Arduino launched their own PLC. I've just kind of lost interest in Arduino as far as anything other than the Uno, because I just think they've lost their way and they've made everything complicated, and I just kind of lost interest. That's kind of the cold hard facts. Don't ask a grumpy old man his opinion if you don't want it. So that's kind of where I stand there. Yeah, Linux guys are angry because they have to read the manual for everything. Want to open a soda? Better read the yeah, they really are into those docs. They're really into those docs. If you think Linux guys are rude, keep talking about curvature of the Earth. Yeah, Cole, okay. Man, you would be surprised. Like, I send a balloon to space, it looks down, it sees the curvature of the Earth, and then I get attacked by the, the flat Earth guys. But it's just like, I think it's great. People can think what they want. I independently think that the Earth is round, because right now, you guys see the sun going down, right? What do you guys see? You guys see the sun going down? Who sees the sun going down, or the sun just went down where you are? What do I see? I see the sun coming up. It sort of works real well with a round world where that sun is coming on around and is leaving your view. I'm on the other side of the world and it's coming into my view. Or I could just be part of the vast curvature conspiracy when I say that that's going on. Okay, let's see. You guys got some good comments coming in here. Can we do something with cloud integration? Probably not. I'm not really into the cloud. I kind of like my data close at hand. Okay, why does the Arduino cost 20 while the Pico is... I'm not sure about the cost. A lot of times it's just availability of parts and price gouging sometimes. Hey, Wise Ninja, welcome back. Haven't heard from you in a while. Okay, we're going to be talking about this. The sun is going down, Chase says. Here, the sun is coming up. Wow, sounds like the world's round. Now, if you want to talk about the Kennedy assassination, now that we could have a conversation about, but we won't get into that. Neither. It is black and night here. Okay, thanks, Vaughn. Sun went down 4 hours ago for Alan. Okay, so that is where we sort of ended up. I ended up having to do a hybrid. And I've lost my cursor. I've ended up kind of having to do a hybrid on deployed systems with some combination of, and really I would use like the Arduino Nano with the Raspberry Pi Zero, and I would kind of kludge things together with that. The Arduino Nano with the Raspberry Pi 0W, and I would kludge together, and whatever I needed to do, I could do by making those two things work together, but not the optimum solution. Now then, as someone came up, hey, wow, thanks, John M. That is really great. Really appreciate that. That is really great. I'm running my generator so that I'll have stable power. And John just paid my expenses for this live stream, my diesel cost of running that generator here for the duration of this live stream. Okay, so we would combine these two and we would make kind of everything work. Then along came this idea of the ESP32, which was low cost, and it was more memory and more powerful, and it doesn't have an operating system, so you can just plug it in and it would work. And they would come with Wi-Fi, or they would come with Ethernet, so it just sounded like the ESP32 was going to be the solution. And maybe for a lot of people, maybe the ESP32 was the solution. So I just started looking, and there were like a million different boards, and there were a million different configurations, and so you really had to be pretty expert at hardware and pretty expert at software and pretty expert at embedded systems to make them work. So then I went to a place like Adafruit that are more designed for, I love Adafruit, by the way. So what I'm saying here is not a criticism of Adafruit. I really, really like Adafruit. Thumbs up, guys, you're doing great. But I kind of went there because I thought they're more designed for the home hobbyist like me. And so let's see what they have going on. Let's see what they have going on the ESP32. But even there, I immediately got confused because there were all these different boards, and they gave all these different names like the Huza and the Huatza and the feathers and the wings and the this and the that, and they just had this whole nomenclature. They had this whole language that I couldn't even get my head around. Like, okay, what's the difference between a Huza and a Huatza as far as the boards go? And you know, it was like, whoa, this is kind of confusing. So then what I did was, okay, I want to kind of understand this, because the number one request that I've gotten on my channel is a series on the ESP32. So from Adafruit, I kind of like ordered one of everything, like, I don't know, maybe $300 or $400. I just ordered one of everything of the ESP32, or whatever that 86, whatever the one that's a little simpler than the ESP32. I ordered one of everything. So then I got the boards in. Wow, Peter. Thank you, Peter. Just took me up with about 10 pounds of coffee. Appreciate it. I get my coffee beans here for $1 a pound. 10 pounds of coffee there, Peter. Really appreciate it. You guys are great. That's a real encouragement for me. I do indeed appreciate that. So I ordered all these ESP32 boards and various things. And then even when I had them, I wasn't sure, should I use this one or should I use this one? Okay, some variation. Well, this one has Wi-Fi, and this one has Bluetooth, and this one has Bluetooth with Wi-Fi. And it was kind of like, you know, okay, I'll pick this one. I'll pick the Huza. And I don't remember if it's Huza. It was something like Huza is what it was called. I don't remember what it was called. But I'll try that one. And then I started seeing, okay, you've got to decide whether to use the Arduino IDE with an Arduino-like environment, or you have to decide if you're going to use MicroPython, which is kind of like the version the world uses, or CircuitPython, which is like a fork off of MicroPython that Adafruit is using for their particular things. And so it was like right there, number one, I didn't know which board to use, and then whichever board I used, I didn't know which environment to use. So if you looked at the number of different boards and the number of different environments, you ended up with a huge parameter space, and therefore there was no momentum developing behind anything. So let's say, okay, I want to put a GPS on an ESP32. Well, a million different GPSs, a million different ESP32 boards, and then a million different ways that you could configure it. So there was not that momentum developing that you had for the Arduino, where there was like one board, one operating system, one way to do things. Everybody used that way. You guys give me feedback. Does it make sense what I'm saying here about the challenge with the ESP32? It was an elegant, beautiful, spectacular, blow your socks off board Okay, but what was the issue? There was no emerging standards, and there was no emerging one way of doing things so that I could figure out how to use a GPS or an ultrasonic sensor. It was just a bunch of stuff everywhere. Therefore, you really needed a lot of expertise. So Savan says that he understands what I'm saying. I'm just looking for a little feedback from you guys. Okay. You guys are kind of quiet out there. Sunil says, yeah, it makes sense. Okay. I still have a couple of basic stamp boards in my closet. Wayne, you're an old timer if you have stamp boards. I never actually did stamps. Like I say, I kind of entered the arena. I entered the arena with the Arduino. Lee says, I agree that what you're saying on ESP32, that's why I like the Pi. Yep, makes sense. Okay. Yeah, guys. And so then I'm sitting here, even though this has probably been out 7 or 8 years, I don't know for sure how many years, but then I kind of ended up with the Arduino Nano, and I ended up with the Raspberry Pi Zero. And yeah, too many options is as bad as too few options. Yes. What's the best mini computer to use for beginners? Not sure how to answer that. Depends on what you are trying to do. But let me let me go on here. I'll try to keep glancing up at the comments. So then all of a sudden, here comes the Raspberry Pi Pico. Okay, here comes the Raspberry Pi Pico. So what's the first thing that you notice about it? You notice that it's tiny. It's almost just the size of the Arduino Nano. And then what is the app? Okay, first of all, I should say about the Pico W, it is much more like the Arduino than it is like the Raspberry Pi. The Pico W does not have an operating system. You download code into it, and when power comes on, it runs that code. So you've removed Linux from the equation along with all of those angry minions, and you've just gotten back to code on a board, code in memory. You've gotten back, one entire huge bloated layer has been removed between you and the silicon. Okay, does that make sense? And so we're back to something that is a lot more like the Arduino. We're back to something that's a lot more like the Arduino. You put the power on, and whatever program is in there is going to run. And now, with this, you do sort of have three choices. You can run an Arduino-like environment, you can run CircuitPython, or you can run MicroPython. Okay, now it's kind of easy because Raspberry Pi is Raspberry Pi. That's a big behemoth. And the direction they're going is going to be the direction that I want to go. And when I go, I don't find 50 different versions of the Pico. There's sort of like the Pico and the Pico W. Hey, I'll pay $2 extra for the Wi-Fi. Maybe it's the difference between 4 and 6 or 5 and $7. So that doesn't matter. I'll get the Wi-Fi version. And now what? I have connectivity. So I have the simple, it just works nature of the Arduino Nano, and I combine it with onboard Wi-Fi for connectivity and a small form factor where there is a momentum developing behind it. And like I say, there's not 50 different boards. Now, what we will expect is over time, we will expect them to upgrade this and come out with newer versions, but it's more of a continued evolution, not I'm going to throw 30 different boards at you and good luck figuring out what you should do, okay? Okay, I'm just looking at the comments here. The Pi, both of Arduino, is the Pi both Arduino and operating system? Okay, the Pi Pico is like the Arduino. You just write the code, you download the code into it, and it runs the code. The Pico itself doesn't run an operating system, if that makes sense. Okay, so then I got really excited about this. I got really excited about this. And the direction that I decided to go was MicroPython. Why? Because, I'm not going to go down that branch with Adafruit because I don't know where Adafruit's going now. You know, I'm kind of gonna go with the MicroPython and not the CircuitPython. Now that's not an irreversible choice. You could always, for this one thing, I really want to use that Adafruit sensor and they got a great library. So for this project, I'll use CircuitPython. And CircuitPython and MicroPython are almost the same. So it's not like you're having to learn something absolutely new. The Pico W does not need Linux. The Pico W does not have an operating system. The Pico W, you just put power on it and it runs the program. Okay, so in my mind, this is the bottom line. Okay, here is the bottom line. The Raspberry Pi Pico W overcomes all of the limitations. And this is the killer. This is the killer. The Raspberry Pi Pico W has analog in. It has analog in. So what does it do? It runs the program on boot. It's simple. It just works. It has Wi-Fi connectivity and it has analog inputs. Boom. In my mind, the Raspberry Pi Pico W is going to be the Arduino killer. And as far as I'm concerned, I'm moving the Arduino off the table, and in the future, my projects are going to be based on the Pi, Pico, and then if I need something else, a little extra help ever, I will then put in there, I will also put in there the Raspberry Pi Zero W, if that makes sense. And so really, when I looked at the pros and cons, there is no problem. There is nothing that the Arduino does that I cannot do on the Pico. And so really, to me, yes, the Pico is going to be the Pico is going to be the Arduino killer. Okay, now you can program the Pico with an Arduino-like environment. I'm choosing not to do that. I'm choosing to go with MicroPython on these lessons. Okay, now the one thing that we still need to talk about, is we need to talk about the user base. Okay, and because it's a Raspberry Pi, I just think naturally there is going to be a user base because everybody knows the Pi. There's already a huge amount of people using the Pi and familiar with the Pi, so that brand name, I think, is going to lead to lots of people using it. And hopefully, kind of like now the question is that are we going to end up with the angry Linux group coming over and being angry with us on the Pico and not answering our questions? Or are we going to try to kind of create our own community, you know, of nicer people who are polite to each other and helpful and encourage each other? Well, you see, what I'm hoping is that with 305,000 subscribers or whatever I have now, maybe we could develop a community of people that are polite and encouraging and maybe start developing a user base around this platform. And so I think what I told you guys, where is it? I will be starting in January a class, and the class is going to be based on the Pico W, and I am going to be using this Sunfounder Kepler kit, or it might be called the Ultimate Raspberry Pi Pico W kit, and I'm going to be using that, and it is going to be starting, the class is going to be starting in January. Okay, so in the link to these is down in the description. Daniel just said that for Black Friday that they've got like them 20% off or something. And so if you're thinking about buying one for yourself, if you're thinking about buying one for Christmas, if you're thinking about asking one for Christmas, today would be the great day to do it because it's Black Friday and they've got them on sale. Look down in the description. There is a link over to Amazon where you can get this kit. And then, like I say, it will be January when I start the class. Now, this is what I've got to say, talking to people like Vaughn and Pascal and Keith and BBF, and I'm sorry, you know, all you guys, Daniel, all you guys that are the regulars. I'm going to go all the way back on this. So this is going to be friendly for new people. So a person that is, say, 12, 13 years old, 14 years old, and has never coded could take this class and could get the Pico up and running and would learn programming, would learn circuits, would learn engineering, would learn STEM, would learn all of that stuff. Now, you guys that are, kind of the bedrock of my channel, you already know all that stuff. And so I don't want to offend you guys, but what I would hope is, I hope you guys would come along on this class and help and encourage, maybe look down in the comments and answer people's questions and make yourself helpful to those people. So we develop a community here that isn't the angry old guys, but it's the grandpas, the uncles and grandpas and dads that are helping people who are just getting started. As we always remember, each of us at some point was a beginner. So that's what I'm hoping is, I'm hoping even though a lot of you guys that are the bedrock of my channel will already know what I'm teaching in those early lessons, I hope you'll join me and sort of help instruct and encourage and maybe do the homework, show your solution, maybe do a more elegant solution than you did the first time that you took the Arduino class. But yeah, I'm going to do things like, okay, we're going to turn the LED on and off. Okay, then we're going to put the LEDs on the breadboard. Then we're going to build a binary counter. Then we're going to do this. We're going to learn what an if statement is, a while loop, a for loop, all those things. We're going to learn those things that a lot of you guys already know, but you can come alongside and encourage the new guys. Let me know what you guys think. Okay, let's see, ESP32 and Pico W, there's not a lot of difference. Tom. It's just that this is the Pico is in a lockdown. This is the way we're going to do it. Okay, so it's sort of like a board that is going to be the way it's going to be done. Okay, I'm in. Pascal, good, great. You're one of the bedrocks of our channel. Savan, I will be ready in January. Great. Okay, hello, Ked here. Wise Ninja, why don't schools teach this to kids? Because the object of the public school system is to teach people to conform, not teach them to think independently. Sorry, don't ask a grumpy old man his opinion if you don't want it. But the goal of public education is to teach conformance, not teach creativity or higher level learning or independent thinking. Okay, Vaughn, thank you. Okay, Vaughn sounds like he's going to be a helper. All right, Stephen ordered the kit. Okay, Lee says, like I plan to follow along from the start. Great. I would like to say thank you. I'm now coding Qt C++. Hey, wow, boom, John, that's great. Okay, the Wise Ninja, I know that. Okay, thank you. So excited for the Pico. I'm looking forward to learning MicroPython. Count me in. Okay, guys, and you guys that are older and more mature, maybe have a couple of extra coins laying around, order a kit for you and order a kit that you're going to give to a young person, either a family member, a neighbor, or someone that you can bring into this, okay? Because we need this younger generation to know this stuff, and they're not being taught it in schools. Somebody, okay, you triggered me on the public schools. You go to the public schools, what they call a STEM class, it's a joke. It is clown world, what a lot of public schools are calling STEM. And it's a lot of pretending you're doing engineering and cutting and pasting what other people have done and drawing little things and doing all of this, but you're not getting in and learning anything. Okay, I said it. I'm sorry. Okay, hey, Ron, got the kit last week. Yeah, I've seen you guys have been ordering them. Any plans of redoing the house? Man, I have a dream that, like, this is my dream, and it's just a dream, but what I really dream is that I could go to a remote village in Africa. Like, I know this one village, and it's called the Village of No Village Beyond. Why is it called the Village of No Village Beyond? It's the last village. It's like absolutely, probably the most remote place on earth. And I would love to take like 6 to 10 kids, bring them to my compound, and then just take these indigenous, just village living in mud hut people and see if I could teach them the Arduino, and then see if I could have these village kids launch a high altitude balloon to space. And I would have to sort of work with the government here to kind of let them know and see if there was any way the government here would get behind a project like that. But that's just sort of like when I'm laying in bed, I have crazy thoughts in the back of my head. That's one of the crazy thoughts, but I don't know if something like that could ever become a reality. The Pico, boom, Peter, the Pico is included. So when you get this kit, it has everything. It has everything you need. I find it awkward that I don't see my kit. Maybe this is it. Yeah, this is the kit, and it is full of delicious electronic goodness. And maybe next week I'll review the kit in more detail. And it's not like I'm not trying to put a sales pitch on you. You know, I get a little revenue when you guys buy this, but I'm not like trying to raise Christmas money here. It's like, this is the direction the channel is going. This is the thing that I see is it. And this kit is really great. Maybe next week I'll go through some of the juicy electronic goodness that is in there, but it does include the Pico W. Yeah, you get the Pico W, and so that is good. So yeah, I dream of teaching African children and have them send an instrument package that they designed to space. Who knows? Maybe someday if I could find like a, like a philanthropic organization to sponsor something like that, because I would have to have all the equipment, I would have to have the living expenses, I would have to hire people to help, chaperone the children, right? You can't just put kids out on a compound. You have to have someone overseeing them. And so that's my dream. Start a little high-tech school from the most remote people on the face of the earth. Then see if you could kind of make a reality show out of it. Like it would be a reality show where you're teaching these indigenous villagers to see if you could teach them to actually get an instrument package to space. Okay, I've probably gone on too long on that. Okay, so there's something that I don't think I made clear. I showed last week that we could boot this thing up. We could boot this. I could start with a blank Pi in the box. I could unbox it. I could configure it. I could install everything, and I could write my first program in under 5 minutes. Okay, but in my rush to do that, also, let's see, I was in a rush to do that. And then the other thing that happened in my rush to do that is my studio was crashing. I was having problems with my studio. So there was something last week that I don't think I made perfectly clear. And so I want to see if I can make that clearer today. And let me see if I can get this up here. I just want to give you a little demo to make sure that I am more perfectly clear. And so let's see if I can come over here. And now we have a code view. Okay, and so let's see. This is my USB cable to my computer. Okay, now I'm going to plug that USB cable into the Raspberry Pi Pico. You heard the happy little sound. Okay, now I'm going to come here. What you're looking at, this window is on my PC. And now I'm going to come over there and I'm going to select the right port. Now I can come up here. I hope you guys can see this. I can say open. Okay, open from the Raspberry Pi. And now I wrote a simple program that is called hello. Okay, so I import machine. Okay, I import time. And then I set up my LED as an output. That's sort of like pin mode on the Arduino. And then I can set it high and then I can toggle it. Okay, and you can't quite see that. And so let's see if we can run this program. Okay, and Shazam, what do you see? Blinking with 5 lines of code. You see how it's got that Arduino feel to it? No operating system, no angry Linux people. It just works, right? Do you sort of see? John M, I am paul.mccorder@gmail.com. Okay, let's see. Are the Elegoo Arduino kit components, Pascal, I don't know. Some will be and some won't be, and so it's kind of hard because there's the whole 5-volt 3-volt thing going, and so I cannot give you a good answer to that. Okay, but do you see how simple that is? Now this is where the magic happens. I want to show you that I'm now going to save that program as where? To the Raspberry Pi Pico. Got to kill it before I can save it, so I stop the program. Now I'm going to say save as to the Raspberry Pi Pico, and I'm going to save it under the specific name main.py. Yes, I want to overwrite main.py. Now what I want you to see is I am going to kill the program. Okay, I am going to disconnect the Pi Pico from the computer. It's powered off. It's operating independently. Now you see I have this, let me get this nonsense out of the way. We're trying to do something here. Now I've got this USB power bank, and now I'm simply going to come in here and I'm going to plug this in. It's always hard to see if you got the right direction. Okay, I plug it in and then I turn the USB on. Shazam! Look at that. You see, we're mobile. Do you see this? I am not connected to my computer at all. I just put power on it, and when I put power on it, it just came up and it ran our little program. Does that make sense? Okay, guys, I hope you guys are getting excited about this. Let's go back and look at the river. It was kind of a rainy morning this morning on the river, and so the fishermen aren't really out too much right now. Okay, power usage of the Pico, that is kind of a complicated thing. It depends on what you're doing with it. So we'll be getting into that in the class. Okay, no, Aman, we're going to stick with the Raspberry Pi 4 series, but that's a good question. Let me tell you the problem that I'm running into right now on the Raspberry Pi. Like, I've gone through most of the components in the SunFounder Ultimate Raspberry Pi kit, and now I'm to the part I'm really excited about, which is the camera. And so this is the problem. The old operating system was Buster on the Raspberry Pi. The new operating system is Bullseye. And Bullseye is intended to take advantage of the 64-bit processors that these things have. And it's the new direction, and it's the direction everything is going. Everything is going towards the Bullseye operating system. Buster is becoming old. It's last generation. It's deprecated. Up until this point, everything that I've done in the class has been on the Buster operating system, because all the things, it's not really going to matter. All the code that we've done so far will probably run on Buster or Bullseye, not a big deal. So using the older, more stable operating system was okay, because it's not going to change when you go to the new one. Now the thing is, though, that things change radically when it comes to the little Raspberry Pi camera. I've got one up here. You know, our little Raspberry Pi camera. I've got a piece of tape on it so I can keep track of it. That little camera, what happened is the way that you used to use that camera was with a Raspberry Vid library, and you could make the camera do what you wanted to with these Raspberry Vid commands. This is the problem. When you go to Bullseye, it did not bring along the Raspberry Vid library. So if I move forward in the class with Buster, I'm going to be teaching you how to use the camera in a way that won't work on Bullseye. So then I make my class obsolete almost from the get-go. But then the problem is when you move to Bullseye, which really, to go to the camera part of that class, we need to move to Bullseye. The problem is they don't really have Bullseye working well with the camera yet. Now I know, yeah, there's that library, what is it, something camera, lib camera or something that they've got to replace the old Raspberry Vid. But this is the problem. This is the thing that would just blow you away, and I've done this before, that if you have the Raspberry Pi, and then with it you have the camera, and then you have OpenCV and run MediaPipe, you can just do some absolutely blow your socks off thing where you're doing artificial intelligence in a portable deployable system. But this is the problem. I can install OpenCV, and I can install GStreamer, and I can get the camera working on here under Bullseye with GStreamer and OpenCV. So we're 99% of the way to where we want to go. But then when I install MediaPipe, MediaPipe upgrades OpenCV to a package that doesn't allow GStreamer, which means when I'm in OpenCV, I can't run the camera because MediaPipe killed GStreamer. And so that is the little quandary that I'm hung in right now. And so we're going to continue to be working in the other Raspberry Pi class on through the rest of the components. We still got some components and a lot of good learning to do, but I am desperately, frantically trying to figure out how to get media pipe with the Raspberry Pi camera and GStreamer in OpenCV. And unfortunately, the only way to get the camera working in OpenCV is to use GStreamer. Okay, and so I've got to get GStreamer to be working with MediaPipe. Does that make sense, or did I just ramble a bunch of nonsense there? Okay, let's see, you guys. I'm looking for some comments here. Is this platform? I'm not using the Arduino IDE, but you can. Thank you for teaching us. Okay, Danny, appreciate the kind word. What's the power usage on the Pico? Is it more? Don't know that. I'm having trouble getting the bullseye to work. Oh, yeah, boom, Ruben. Getting the bullseye to work with the cameras is kind of where the challenge is right now, and I'm working on it. I've got most of it done. I just sort of said what the problem is. Get BBF on it. Yeah, BBF. Why don't you be helpful? Where is BBF this morning, by the way? That scofflaw, he's slacking off on us. Okay, so that is, okay, Rob says, I have already ordered Pico, but how do I know if it is a W or not? Well, when you ordered it, it should say W. But the nice thing is, man, just if you can, just get the kit, because then you'll have everything that you need, and it's like a huge value. It's on sale today. Okay, guys, I am right over the 1 hour mark. Maybe next week, if you guys are interested, let me know, and I'll go into more details of what we have going on in the kit, the things that we have in the kit, and the things that we'll be doing in the class, and then also get some feedback for you guys. So maybe next week, what I'll just say, review of the kit, just sort of review. I'll do a review video as a live stream, and then what we can do is have a nice chat. Okay, guys, I'm going to be wrapping things up. If there's not any last minute questions, I'm still looking here to see if you guys are going to ask any last minute questions. Okay, thank you, Vaughn. Really appreciate it. God bless you as well. We always appreciate your kind thoughts there, Vaughn. Okay, Lee, appreciate it. Okay, guys, I think this is where I will be signing off. So you guys order your kit, order one for someone else, get people into this class. Why? Because the world needs more people doing coding and engineering and fewer people sitting around watching silly cat videos. Paul McQuarter with TopTechBoy.com. I will talk to you guys later.